So we're recording now, and the question in particular is just some calculus question where they give you two functions. I don't know what you want to call them, like f and maybe g. I'm using, I'm basing the picture off of the given function, but I'm going to use different values. In fact, maybe I just won't even use values. But the idea here is one of these functions is f and the other one is g. I guess this is f of x and this is g of x. And they're saying that u of x is equal to the product, and g of x and v of x is equal to x times. Okay, yeah, like that, right? So what they're asking you to do is finding u prime at some point. You can call it anything, right? It doesn't really matter, just at some constant c. Let's maybe say at the value of 2, right? It's not that different. You just okay. That's maybe a bad example. I don't know. Call it 0. It just needs to be at a point where the derivatives are defined for both of these. So like, I think at 2, this one happens to have a cusp, so that's not a great example. But for anything else, it's perfectly fine. And if you want to figure out what this is, you basically just figure out first the general expression for u prime of x. And by product rule, we know that u of x is equal to fx gx. So the definition of product rule is basically just f prime of x, g of x, plus f of x, g prime. So far, so good?
Yeah.
Right. So we know the idea here is, okay, so maybe let's just plug in 0 at this point. This is basically saying 0, u prime of 0, or whatever your point of interest is, your x value of interest, you just plug in 0. G of 0 plus f of 0, g prime of 0. So what this is saying is, okay, there are basically 4 unknowns, and we need to get all of these from the graph. We need to get all of these from the graph. Okay? And well, g of 0 and f of 0 are pretty straightforward. You literally just read off the value at the point of interest, right?
Yeah.
So that leaves the question, what exactly are g prime of 0 and f prime of 0? What are they? Can you tell me what the graphical interpretation of the derivative at a point is?
I cannot.
You cannot. That's okay. The very first time you're learning them, these things are probably kind of mysterious. But remind yourself, these are just the slope. The derivative at a of a continuous function, or at least a function that's differentiable, is the derivative at that point is just the slope at that point. So that's basically saying, okay, go to the point of interest and just tell me what the slopes are. Just tell me what the slopes are, and then plug that right in.
So, wait, can you scroll back up to the graph part?
Sure. So
So, if your point in question is 0,
mhm.
so you're finding the slope of that line?
Yeah,
Because
so I'm finding the slope of f at this point, and I'm also finding the slope of g at that point.
okay, because okay, and then you would just do it by like reading the graph to find the slope.
Exactly.
Okay, because um it's it's like, see how it's like a zigzag line kind of.
Sure. Yep.
So you're just finding the slope for the line that the point is
Just
in.
look right here. Just look right around here. Right? It's the stuff over. I understand your concern because over here, it's like, oh, it's a different slope. What do I do? But I'm not
Yeah.
asking about those points. The question is just asking about at a specific point. Right?
Okay.
So just go do like rise over run, literally rise over run, and tell me what those. Okay, what's going on with my pen? Use the rise over run just locally to figure out what that slope ought to be. Sound good?
Mm-hmm.
Okay.
Yeah, that
So
helped.
just to give you a little bit, so that should give you a very general idea, but just because I know that students starting out tend to be very, it tends to be a little bit scary when you see things a different way, I'll just get you sort of started a little bit with a v prime of x. So v prime of x is the quotient rule rather than the product rule. And if I remember correctly, the quotient should look something like, gosh, I hate using the quotient rule. And what I like doing instead is just using the product rule. The product rule really actually can do the quotient rule if you just represent g of x as if instead of representing its division, you just write it as to the raise of the negative 1 power for the reciprocal. And the way you do this is this just becomes f prime of x times g of x to the negative 1. Negative 1 just means reciprocal, right? Just flip it under the division sign. Plus, well, I guess this turns into minus f of x, g of x to the minus 2 now, because we use the power rule, times g prime of x. Yeah, I always hate using the division rule. The product rule is always, pretty much always simpler. But yeah, at this point, it's exactly the same idea. It just looks a little bit scarier because it's more complicated, right? And go double check with your division rules to make sure that I've actually done this correctly. But I'm pretty sure that's the same result as the quotient rule. So you could just look that up in your textbook, right? But the idea is, again, plug in 0 or whatever point of interest you have, and then at that point, just figure out what f prime at 0 is, and then what g of 0 is, and just divide by that. And similarly for g prime and f. Does that make sense? You good?
Yeah, that makes sense.
Very good. Alrighty. I guess we'll end recording right there.